Don't be fooled into thinking this is the same as the one that was on the learning goal that we just did or that we did last week. It says two numbers have a difference of 12. So that part's the same, but the next part is a little bit different. So again, we got to just set it up right. After that, everything else is the same. You're still doing the same, completing the square process and that kind of thing. All right. So what do we always start with? Let statements. Let x represent one number. And remember last day, I showed you how like your let statements can take two different forms. You could use two variables, or sometimes you can get away with just using one. This is the type where you could get away with just using one, or it's easier to, but we're going to use two to see what that looks like. So let y represent the other number. And so if the two numbers have a difference of 12, what's the relationship between x and y? This is what you have to be able to think through. X minus y equals 12. The difference is 12. And then what you want to do is take one of them over. So I'm going to take the y over. In this case, that's going to be the easiest. X equals 12 plus y, or y plus 12. You might want it written that way instead. Doesn't really make a difference. But again, we usually write it this way, so it's a bit more familiar. So that might be, I would imagine some people would always prefer it to look like that. Good so far? That's like step one. Let statements and kind of get our little expressions there. And what we've done so far is we've sort of dealt with this part, difference of 12. So what is this part? The sum of their squares, and this is where some people just trip up on the language that's involved. And there's two different kinds of questions, the sum of the squares and the square of the sum. You might have seen in grade 10, but we're going to skip the square of the sum. So that's nice. So the questions will kind of, for us, always be the same. So what does it mean, the sum of the squares of the two numbers? What does sum mean? Not product. When they're added together. Sum means added together. So I'm going to take the two numbers and I'm going to add them. And one of the numbers is x and the other one is y. And I'm adding them, but I'm not just adding them, I'm adding their squares. So what does that mean? Square and square. And I'm going to use a capital S for that. You don't have to do x plus y if you don't want to. You could go straight to the next step, because what is x? It's y plus 12. So this is y plus 12. And this is the key step to getting this set up properly. Is the sum equals this one squared plus that one squared. Does that make sense? It really helps if you think about this, because it might look easy when we're doing it now, but when you go and try to do this yourself and all the other types are muddled up and mixed with them, it can be harder. But this is one of the numbers, because this is the same thing as x. That's what it says right here. And then this is the other number. So I'm summing the squares of those two numbers. And then how do we always solve? How do we always find the max or the min? Yeah, so we are going to complete the square, and the first process towards that is going to be expanding these brackets. Don't forget, this is y plus 12 times y plus 12. Don't forget, y plus 12 squared does not equal y squared plus 12 squared. That's the mistake that everybody makes. Not everybody, but like so many people make that mistake. Okay. It's y plus 12 times y plus 12, which is y times y, so y squared, y times 12, 12y, 12 times y, another 12y, and 12 times 12 is 144. And so if you remember this pattern, we've started talking about it a fair bit over the last week or so, is I get the 12s added together to give me the middle term and multiplied together to give me that third term. And now I can put the two y squared terms together. that should be 2y squared. Whoops, that was the whole point of that. 2y squared. And all of that work was just to simplify it, to get it into this form where we can continue to complete the square. Why don't you go ahead and see if you can continue from that step? I will as well. Okay, so I didn't get very far yet. So most of you probably are further than me, but this is what I did. I just pulled out the 2, and I divided the 24y by 2 when I pulled it out, because if I was multiplying it back through, it would be 2 times y squared and 2 times 12y, which would give me the 24y. And then what do I do to complete the square? I look for a number. This is the important part of the process. I take half after this is a mistake that some people would make, right? They would forget to divide the 2 out of the 24. And when they add brackets to the question, it would still say 24y there. But it should be 12y because I divided the 2 out. And then I'm looking for a number that relates to the 12. So I take 12 and I divide by 2. I take half of 12, which is 6. Square it, which is 36. Add it and subtract it. And then close the bracket. And then take the -1 outside the bracket, and that way I have a trinomial, 3 things inside the bracket, which is a perfect square trinomial. 2 times -36 is -72, plus 144. And then I can write this in its finished form, y plus 6 squared plus 72. I remember I was kind of saying on Friday, I guess it was, how like you get to this point and these questions are sometimes tricky because it doesn't just give you your answer. It's not like when you're calculating the volume of something and it's like V equals 700, right? And that's your answer. This one is an equation, so we have to interpret our answer. So if I think about this as a quadratic, it opens up. Therefore, it has a minimum value. And at the minimum of 72, 76, whoa, where'd that come from? Of 72, which occurs when y equals -6, because I've shifted to the left 6, right? The h value is -6, so I'm shifting to the left 6. So my vertex would be at -6 and positive 72, and it opens up from there. So what is the minimum sum of their squares? We're going to say what the numbers are and what the minimum sum of their squares is. My numbers were, going all the way back up to the top, x and y, but x is equal to y plus 12. So if y equals -6, x equals y plus 12, which equals -6 plus 12, which equals 6. And remember, I kind of told you last week, I gave you that little hint that that'll almost all these questions work out to like -6 and 6 or 6 and 6, right? So therefore, the two numbers are -6 and +6, and the sum of their squares is 72, and I'm going to show you what that means in a second. 72. So remember, it all started with this. The sum of their squares. And if we know those two numbers now, I can do that by going one of them squared plus the other one squared. And if one of them is -6 and the other one's +6, you get 36 plus 36, which is 72. And I think we talked about this a bit last week, but just briefly, it might help some people who struggle, like, okay, I understand all the steps, I know how to complete the square, I can do all the algebra, I can do the let statements even, I can do all that stuff, but I don't really understand what this question is even talking about. But if you think about it, you can come up with all kinds of pairs of numbers, right, that have a difference of 12, like 20 and 8 is another pair of numbers that has a difference of 12. And if I do 20 squared plus 8 squared, I get 464, so I get a bigger number. Turns out 72 is the smallest number you can get when you take two numbers that have a difference of 12 and you square them and then add them together. 72 is the lowest number you're ever going to get. So that's what that means. Not very useful, maybe not very interesting, I don't know, but it's one of these problems that we use to just kind of practice this stuff. What do you think? Any questions? Everybody okay with that? But this one's different because yesterday, when we looked at them, it was just find the minimum product. Two numbers who have a difference of 18, or two numbers that have a sum of something. So that was just a product. Or if we were doing like shapes, which is similar to the product question. So what was different about this one was the sum of their squares part. And that can be confusing to some people. Okay, and then we got one more to do. And sorry, it's a little bit longer to write down. So this is a very special type of question, a revenue question. And there's one trick to these, and you've seen them before in grade 10, but if you hadn't ever seen them before, it would be really hard to come up with this little trick, okay? So we're going to go over it once together, and what you have to know is every revenue question is solved the same way. You need to get started, you need your let statement to be set up properly. If you didn't get that started, the whole question would fall apart. Okay, so that's the most important first step to these, is getting your let statement right. And then there's another part to it that, again, is maybe not super obvious until you've practiced a few times. So you want to make sure you've practiced a few times and that you've got it. So it gives us the price. This one's about a coffee shop. It gives us the price of a cup of coffee, which is $2 per cup in this case, and how many cups they sell. And then it's somehow it's got this magical consumer survey where they've discovered that if they, in this case, increase, sometimes they decrease the price, sometimes they increase the price, but in this case, they're increasing the price. So if they increase the price by 5 cents, they will sell 100 fewer cups, and that makes sense. If you increase a price, you won't sell as much. That's just in general, that's true, right? If you take a product and you decrease the price, you'll probably sell more of that product. When you have a sale, you have more, you'll sell more of them. Companies do this for different reasons. Sometimes they're trying to get rid of stock. They're just trying to sell out what they have because they don't want it anymore. Sometimes they're playing with the idea that, well, if we decrease the price just a little bit and we sell like 3 times as many of the product, we'll make more money overall. We're not making as much per sale, but if you can sell enough, you'll make more money. And so that's what companies always want to do, is maximize their profits. So, so companies play with this idea, right? So that's what this question is talking about. Before we get to the let statement, I'm going to summarize some of this information. So the current price, and you may want to do this. Some of you may like to do this. I don't know that you really have to write all this out. Oh, sorry, not the current price, the current revenue. What does revenue mean? It's not profit. I used the word profit before, so this isn't actually talking about profit, but it's related to that, obviously. Revenue is just the money that you bring in. Okay? So it obviously costs companies money to make the coffee, but that's not what revenue is about. So revenue is just the money that you bring in. So what is going to be the current revenue? Right. $2 times 6,000, which equals 12,000. There's a couple of reasons why this is useful, because it reminds us that revenue, actually I'm going to do it over here. So that means revenue equals price times number of sales. That's how you find revenue. And the current price was $2 and the current sales was 6,000 cups in a month, I think, right? Yeah, in the month. So what we have to do is we have to come up with the new price and the new number of sales, expressions for those things, and then when we multiply them together, that'll give us the revenue. Come up with an equation for that, put it through our maximizing process, and then you'll have your answer. So the last one I said, not very interesting, not very useful, the sum of the squares, but this one would be. And companies probably do something like this. It might not look exactly like this, but probably have systems, and their computers would kind of do it for them. They wouldn't be doing it on paper, but they would have this kind of a process built into their systems. Okay, so I said one of the most important things was your let statement. Does anybody remember from grade 10 what the let statement is? Let X represent, some people might guess, the new price. That's not going to work. Or the new number of sales. That's not going to work either. That's exactly right. So we don't know how many times we want to increase the price to get the maximum. That's what we don't know. We also don't know the new price or the new revenue or the new sales, but we don't know how many times to increase the price. So that's what we're going to let X represent. Let X represent the number of price increases or 5-cent increases or something like that. Actually, I'm going to even change that to $0.05 because notice that it's written in cents, but the cost was in dollars, so we can't have them in different units, right? The number of 5-cent increases. And what's really important is that you do that. Every revenue question starts with that let statement. The number of increases or the number of decreases. Then we're going to come up with an expression for the new price and the new sales. Then we're going to multiply them together to find an equation for revenue. Yeah.
To skip over this, could we just add 5 cents on $2 and subtract 100 from 6,000?
And just like.
And then just multiply 2 $2.05 times.
But that would only be one increase.
Then couldn't we just keep doing that
That would find it, but it's super inefficient. What if the maximum increase occurred at $10? That would be hundreds of increases. You'd have to do it hundreds of times. So it'd be super inefficient. And we are learning to solve these problems with quadratics. So that's not going to help us learn what we're supposed to be learning, right? But it would work. Yeah. You'd keep going. And because as we know it's quadratic, you'd keep going until all of a sudden one would get lower again. And you'd be like, okay, the last one was the highest. Yeah. So how do I find my new price? But not just 5 cents. How many 5 cents? So it's going to be $2 plus
5 cents times the maximum.
not the maximum, but you're on the right track.
Times the number.
Yeah, the number of increases, which is times x. That's right. So it's going to be 0.05 times the number of increases, which is x. And again, all of these are the same, so you could like kind of memorize what to do, but if you understand it, I think it'd be a lot easier. So what does this mean? Well, if we do 5 increases, if we increase the cost 5 times, it'd be 0.05 times 5, which would work out to 25 cents, I guess, right? It'd be 225 would be the best price. That would maximize revenue. You'd have fewer sales, but you'd make more money overall. So if you increase the price 10 times, it'd be 0.05 times 10. So, but we don't know how many times. It's x, so it's 0.05 times x. And the new sales will be the old number of sales, which is 6,000. And we're subtracting, every time we increase the price, we subtract 100. So it's going to be minus 100x. Does that make sense? And one of them is always adding and one of them is always subtracting. This one says we're increasing the price and decreasing the number of sales, but some of the questions flip-flop that. Okay? So I have an expression for the new price, an expression for the new sales, and remember we already determined that revenue equals price times sales, so that means my revenue R is equal to the price 2 plus 0.05x times sales, which is 6,000 minus 100x. And this is going to give me an equation that if I find the maximum of it, I'll have solved the problem. But how do we do it in this case? Expand everything, simplify everything, put it in the form that we like, complete the square, same process as always. Whenever you're doing a max or min problem, it's always completing the square that we're talking about, right? Oh, no. Any questions? So this one's about, you can go ahead and start it if you want, if you think you know what to do. If you're not sure, well, we can do it together. But you are going to expand, right? So I'm going to do this times this and this times that. And then I'm going to do this times this and this times that. 2 times 6,000 is 12,000. 2 times negative 100 is negative 200x. On my calculator, 0.05 times 6,000 gives me 300, so that's plus 300x. And 0.05 times negative 100 is 5, so negative 5, and be careful, x squared. You got to have an x squared term in there somewhere, right? I'm going to add the two x terms together, and I'm going to put it in the order that we like. So I move the x squared term to the front, negative 5x squared. 300x minus 200x is plus 100x plus 12,000. Does that look like the quadratics that we're used to solving, working with? So we're going to complete the square. So you can go ahead and start that. But again, what's the first step? Negative 5. And remember, the mistake that some people make is they forget to divide it out of the 100. So make sure you divide it out, and you should get negative 20. And then I'm going to Pause there to let you try to do the rest. Now here's where you get to find that number, right? Okay, so that's what I got. So I take half of 20, which is 10, square it, that's 100, add and subtract. Take the negative out, don't forget to multiply it by -5, becomes positive again. That's going to be pretty important. If it didn't, then something would be wrong. The question wouldn't make sense, and you can think about why. And so then again, I always like to do this. You don't have to write this out, but you can if you want. This opens down. Therefore, it has a maximum. It has a max of 12,500, right? So why is it important that this 500 was positive? Because remember, the old revenue was 12,000. The original revenue was 12,000. So if we're making that bigger, if we're maximizing it, it better get bigger. So this has a max value of 12,500, which occurs when x equals 10. It shifted to the right 10. So when x equals 10. And what is x? Again, somebody remind me what x is in this case. The nice thing about let statements, some people find them just a pain and they hate doing them and they're like, I don't like writing, I just want to solve the problem. But the nice thing is when you get to the end, you can be like, wait a minute, what is x? And you can go back and actually read your let statement.
It's the amount of increases.
It's the number of increases that will maximize revenue. So if x is 10, what does that mean? That means, therefore, 10 increases. This isn't my final answer. I'm just kind of thinking right now. 10 increases in price. And there were 5 cents each. So now I can actually calculate the new price, which was the $2 plus 0.05 times 10. So that works out to $2.50. And the new number of sales, again, the question might not ask me to find this. I don't know. But I'm going to find it anyway, because another question in the future might. So it's good for us to have a record of it. Was 6,000 minus 100 times the number of price increases. So 100 times 10 is 1,000. So that's 5,000. And the revenue should be 250 times 5,000, which gives me 12,500, which we already knew was the max revenue, right? And let's see what this question said. It said, what should the selling price be to maximize revenue? So the question A, the selling price should be $2.50. Again, this one's tricky because you get to the end and you think you're like, therefore x equals 10. But that's not the question you were asked. That's the number of increases. So you always have to go and interpret. That's why this is a really good question, because it reminds us that we have to actually answer questions. We're not just doing a mathematical process. We're answering a question. So the selling price should be $250 to maximize revenue. And question B is, what is the maximum monthly revenue? The max revenue is 12,500. And it occurs at 5,000 sales, $2.50 per sale. Everything all adds up. hopefully. In this case, it does.